So we talked a bit about equations. Inequations, how do we handle inequations? And basically it's exactly the same as solving equations. The difference is we can have multiple answers. And the other thing to watch out for, the inequality sign when we're dealing with it. You change the sign in these situations when you multiply or divide both sides by a negative number. So the way I remember that is if you change the sign, you change the sign. So you change the sign of the number, then you change the sign of the inequality as well. So if you change the sign, you change the sign. The other one, it's rarer that we do it, but if we do it, if you take the reciprocal of both sides, then the inequality sign should swap around. Example of that. Well, 2 is less than 3. But if you were to turn both sides upside down, a half is greater than a third. So when you flip upside down, you change the inequality sign. As I say, that's a rarer one. It's more number one there when we multiply and divide by a negative. That happens a lot more. A very simple one, of course, but let's use it for the sake of an example. 6x divided by 36, as I say, exactly the same as I would do with an equation. It just becomes x is less than 6, so we have a whole heap of answers. Often we plot these solutions on the number line. You don't have to put 0 on your number line. Some people are obsessed with got to have 0 for some reason. Usually the number you're interested in, maybe one either side to give it some sense of scale. It's not included, so we circle the number that's not included, and then we just draw an arrow indicating which way we're going. I personally like to draw my arrows slightly above the number line. Some people put it on the number line, but I find depending on what colour pen you're using, you might lose it with the number line. So it's a lot easier, I find, when you put it slightly above, and then it's clear where your arrow is and what direction it's going to. I guess the other big difference with an inequation as an equation is you can have more than one side. Here has 3 pieces. So a left-hand side, a right-hand side, and a middle. If you think of equations like what I do to one side, I do to the other, well, same deal here, but it's like what I do to one thing, I do to everything. So here, I want to get the x by itself. So the first thing I will do is I'll subtract 6, but I subtract 6 from everything. So I now have minus 4 less than or equal to minus 4x less than or equal to 8. Now I'm going to divide by negative 4, but everything. But if I change the sign, I change the sign. So the x is now positive, so all my inequality signs have swapped around. Now, of course, that looks horrible. I don't leave my answer like that, or I'll go into a cold sweat or something. But that's better. Oh, so much better. So minus 2 less than or equal to x less than or equal to 1. On a number line, I'll just put the 2 main points for this one. They're included, so I colour them in, and I'm in between them, so I put my line in between them. That brings me to this, the, in inverted commas, correct way of writing inequalities. Translations, Mr. Simmons is very fussy. I personally think that your algebraic solution should look like the geometrical solution. So they look the same. What do I mean by that? Here's the geometrical solution. I've drawn a picture. There's the algebraic solution. See, it looks like it. The greater than sign's going in the same direction as the arrow. It looks like the picture. I don't write it like that. 5 is less than x. And the other reason I guess I don't write it like that is, what is an inequation saying? It's saying, hey, what are all the possible values for x? And in the first line I'm saying, well, x can be bigger than 5. Excellent. Whereas the second one's saying is, 5 is less than x. Yeah, but I'm not interested in about 5, I'm interested in x. So thanks for telling me 5 is less than x, but what's x? So to me, x is greater than 5 is just a much better answer. So in between, again, it looks like the picture. X is in between 4 and 6, 4 is on the left-hand side, 6 is on the right-hand side. I wouldn't write it like that. It doesn't look like the picture. When do we see 6 on the left-hand side of 4? You don't. And you definitely don't do that. X is greater than 4 or x is less than or equal to 6. That's just plain wrong. Because if you think about it, if I'm saying x is less than 4 or x is less than or equal to 6, that's every number. Every number would satisfy that. Because any number you pick is either going to be greater than 4 or less than or equal to 6. Somewhere it'll be both. But every single number would fall into that category. If you were going to do it with two separate ones, and would have been the correct word there, not or. We say it's that and it's that. But I just steer away from that, use the first line. Something like this, when the solutions are on the outside of 2 points, I would write it like that. Again, it looks like the picture. X is less than or equal to 4, it's going to the left. X is greater than or equal to 6, it's going to the right. It looks like the picture. I wouldn't write it that way round. Now technically it's not wrong, but it just looks ugly. It's pointing inwards and horrible. Okay, it's got to look nice. And I certainly wouldn't do something like this, and I've seen this before. Oh yeah, I'll write it like that. Again, that one is just plain wrong. Right? 4 is greater than or equal to x, which is greater than or equal to 6. Well, how is that possible? How can 4 be greater than or equal to x, but x is greater than or equal to 6? There's no numbers that do that. That's impossible. Let's now go to actually solving different types of equations. And the first one we look at is the quadratic inequations, because the simple linear ones, yeah, sure, that's two stuff. We've seen it in there. Quadratic inequations, we step it up a bit. So x squared plus 5x minus 6 is less than 0. We still solve it initially like a quadratic. So if I can, I'd like to factorise it, which I can. But this is where we don't do it the same. Because if it was an equation, I simply would have said, oh, that means x is equal to negative 6 or x is equal to 1. It doesn't work with an equation. It's not true to say x is less than negative 6 or x is less than 1. That is not correct. If you think of the picture, then the solution becomes a little bit easier. If I was to draw this, it's a parabola. X-intercepts are 1 and negative 6. I know it's concave up. I'm only interested in the x values, so we can think of the x-axis like the number line. So I've circled the 1 and the minus 6. But this question is now saying, well, what values of x is this parabola below the x-axis? See, all those points, it is true, but I'm only interested in the x values. So if I was to plot all those, I would be plotting in between minus 6 and 1. And now graphically I've got the solution. I know what the solution is now. So the solution is x is in between minus 6 and 1. The same thing could be achieved without drawing the graph, just by substituting a point in. You see, minus 6 and 1 are what we call critical values, or critical points. These are the boundaries of the inequality. So all I have to do is to check inside the boundaries. Does it work or not? So I could have just substituted in 0 and looked at it and went 0. Oh, negative 6 is less than 0. Yeah, it is. So I know 0 had to be included. Therefore, I'm in the middle of these 2 points. So you could do it that way as well. Let's do another one. Personally, I hate it, the negative x squareds. So I'm going to multiply everything by negative 1. But if I change the sign, I change the sign. So it's now greater than or equal to 0. That does factorise, I think. Yes, it does. X plus 4, x minus 1. So my 2 critical points, negative 4, positive 1. Well, they're included, so I make them solid. Concave up, but this time it's saying when is it greater than 0? So when is it above the x-axis? Oh, well, that's for the x values that are on the outside this time. So my solution is x is less than or equal to negative 4, or x is greater than or equal to 1. So I still think with inequations, the easiest way of solving them are finding those boundary values, finding those critical points, and then testing. And just think, okay, am I this side of the point or that side of the point? And pick a number. With quadratic inequalities, your solution will always be one of these 2 things. You're either going to be in between the 2 critical points or on the outside of the 2 critical points. So it's just a matter of working out which way round it's going to be. Absolute value inequation. Absolute value of x plus 5 is less than 2. This is where using the definition is good, because it's either x plus 5 is less than 2 or the negative of x plus 5 is less than 2. On the left hand side, I get x is less than negative 3. On the right hand side, a little bit more work to do there, but I get x is greater than negative 7. So I just plot myself a solution. So I found these 2 critical points, negative 3 and negative 7, and this is what it's telling me. Well, it's got to be the point of intersection of these two, because both of these things have got to be possible. Therefore, I'm in between. So I did it with a graph, but again, I could have just picked a number. If I had picked 0, I'd see absolute value of 5 is 5. Is 5 less than 2? No, it's not. So I know 0's not included. Therefore, I'm not on the right-hand side of this critical point. I must be on the other side. So I'm in between these two. Absolute value of 3x plus 2 is greater than or equal to 1. Same idea. Either the negative or the positive. Solve the positive one, I get x is greater than or equal to negative a third. Solve the negative one, I get x is less than or equal to negative 1. I've got my two critical points. If I was to draw these two, I get like that. There is no point of intersection. So in this case, it's the one where we're on the outside. Again, I could pick a number. 0, I mean 0 is so easy to substitute. If you can use it, use it. If I sub 0 into this, 2 is greater than or equal to 1. Yes, yes it is. So I must be on the right hand side of the negative third. I'm on the outside of these 2 points. You can always turn your absolute value equation into a quadratic and then use that technique. So let's look at this one. Absolute value of x plus 5 less than 2, the one we just did. How do I turn it into a quadratic? I square both sides. You see, squares are always positive, just like absolute values are always positive. So I can do that. And I've changed the question now into something different, which I know how to solve. Let's expand it out. There's my two critical points, negative 7 and negative 3, same as I got before. I can test a point and I get the solution we got before. So you could always turn it into a quadratic if you wanted to. I'm not saying it's the best way of doing it. I'm just saying it's another way of doing it. Second one, same deal. I'll just square both sides, turn it into a quadratic. I get the two critical points of minus a third and minus 1. Check the points. I get my answer. Inequations with pronumerals in the denominator. How do we do this? I reckon I know about 5 different ways of approaching these questions. Start with a very, very simple one. 1 over x is greater than or equal to 3. What's causing me the problem with this is the denominator, because we know that the bottom of the fraction can't equal 0. That is going to create a boundary point, a critical point. So I know x cannot equal 0. So x equals 0 is going to be a key part of this solution. Then just solve it like it's an equation rather than an inequation. So 1 over x is equal to 3 gives me x equals a third. Plot them on the number line. There they are. Notice the 0 I've not coloured in because it can't equal 0. Bottom of the fraction can't equal 0. The 1/3 I have coloured in because, go back to the original question, it's greater than or equal to. So it's allowed to equal that point. Now I just test. Unfortunately I can't use 0 for this one because it's one of my key points. So I just pick another easy number. So test negative 1, I get 1 on negative 1 is greater than or equal to 3. Well no it's not. So I know negative 1 is not part of my solution. And if I'm really unsure, let's test some more points. A quarter, that's in the middle of these two. I get, yeah, that one works. I know I'm in between. But just to make real sure, I'll test 1 as well. 1's greater than, no, that's not part of it. But then I've got the picture. If I've got the picture, I can write the algebraic solution down quite easily. Can I tell you, from marking the HSC for many years, and I've marked this type of question a few times, that is the most successful method. It's not the most common method that people use, but the people that use this method, more of them get it right, percentage-wise, than other methods. The most successful. Okay, let's do it again with this one. All right, what's causing me the problem? Bottom of the fraction can't equal 0, so I will solve that. X can't equal negative 3. I've got one of my key points. I've got my critical point. I will solve it like an equation. Okay? I get x equals negative 13 on 5. Let's test some points. Let's try, negative 5. Let's try negative 5. Put that in. I get negative 1. Is negative 1 less than 5? Yes, it is. If I pick a point in the middle of those two, gosh, what's in the middle of those two? Oh, 2.5. I think that's in the middle, isn't it? 2.5. So if I try negative 2.5, I get 2 on it. I get negative 4. Oh yeah, no, that is less than, no, work your maths out. Come on, that's positive. No. But on the right hand side, it is. I have my solution. You'll find with these simple linear ones, because these are linear, that again, you're either going to be inside or outside. Be careful though, not all inequations are like that. There's my answer. I will now show you the most popular method, the most successful method, the most popular method, and the one that I found tutors love to show you. 1 over x is greater than or equal to 3. How do you do it? Again, we turn it into a quadratic. Multiply both sides, not by the denominator, but by the denominator squared. And the reason you do that, you have to multiply by a positive number. And you don't know whether x is positive or not. So simply multiplying by x, you don't know whether you have to change the sign or not. But if I multiply by x squared, I know, it doesn't matter what x is, x squared will be positive. So I can multiply by that and the sign won't change. So that's why we multiply by the denominator squared. Okay, if I do that, I end up with this quadratic eventually. 3x squared minus x is less than or equal to 0. Solving that, factorise it, I get my 2 critical points again, and away we go. But to me personally, look how much work you just did to find those same 2 critical points that we did the other way. And you have to solve a quadratic rather than in the other method, you're only solving a linear equation. Well, linear equations are easier to solve than quadratic equations. Why make the question harder for yourself? Take care of the domain issue, because that's the other thing. By doing it this way, you tend to forget, because notice, I've got equal to as well. Because when I solve this equation, I've got equal to. But x can't equal 0. It's on the bottom of the fraction. So I now have to remember that as well. So x can't equal 0. In other words, there's our solution. Let's do the other one we looked at. So I would multiply both sides by the square of the denominator. Now when you move it over, for goodness sake, do not expand all this out, because they're both going to have a factor of, in this case, x plus 3. So some of the factorization has been done for you already. So if you are going to use this method, leave it like that, so you can then say, oh, it has a common factor of x plus 3. What am I left with? 5x plus 13. You can then work that out. That gets us the 2 critical points. We can test either side, and away we go. Okay, so as I say, that one, the most popular method. The first one, the most successful method. So I guess it comes down to you personally and your egos. What would you prefer to be? Successful or popular? All right, 5A. Let's have a go at those.